Hello, this is Eileen, the environmental educator. In this video, we're going to talk about something that made headlines at the beginning of the summer. This is June 19 article. Earth's rotating inner core is starting to slow down. It could alter the length of our days. Well, it can also have an effect on the magnetosphere, which plays a key component in keeping Earth's deadly ultraviolet radiation away from the Earth. So this was also in space.com on a June 21st article. The inner core is slowing down. USC, University Southern California, they confirm it. And this was June 12th, 2024. And they say it began to decrease around 2010. Now, back here in January 2023, they thought that it stopped spinning and changed directions. But right now, the newest science, a year and a half later, confirms that Earth's inner core has been rotating more slowly than usual since 2010. The mysterious backtracking could also end up slightly altering the planet's overall rotation, lengthening our days. And then they say that any potential change would be on the order of thousandths of a second, which would be very hard to notice. So right here it says, the new study shows that the inner core's slowing speed is caused by convection within the liquid iron outer core, which sustains Earth's magnetic field, and the pull of the gravitational forces in the overlying mantle. This article says, if the Earth's inner core rotation continues to decelerate, its gravitational pull could eventually cause the outer layers of our planet to spin a little more slowly, altering the length of our days. So that's how that would happen. Once the inner core slows down, then the outer core that surrounds it would just slow down by default. Now, that's just what they're thinking. Here's the Earth's inner core, and then the outer core. Now, the inner core is solid, and the outer core is liquid. So, being inside the liquid core is how the solid inner core could rotate slower than the mantle and then the crust, because it's floating in this liquid outer core. The size of the inner core is about the size of Earth's moon, and the size of the outer core is about the size of Mars, just to let you know the size of Earth. You could fit the moon and Mars inside of it, and you would still only be at the outside of our inner core before the mantle and then the crust. And to realize that the inner core is rotating slower than the rest of the planet, researchers analyzed seismic data recorded during 121 repeating earthquakes that occurred around the South Sandwich Islands in the South Atlantic between 1991 and 2023, as well as data from several nuclear tests around the globe. They wanted things that started in different locations. They didn't want every test to just start from the same place, so they used different earthquakes and nuclear tests from around the world. So we're all like, hey, 1,000th of a second, who cares? That's not the biggest deal in the world. Well, the bigger deal is Earth's magnetic field. It says enveloping our planet and protecting us from the fury of the sun is a giant bubble of magnetism called the magnetosphere. It deflects most of the solar material sweeping towards us from our star at 1 million miles per hour or more. Without the magnetosphere, the relentless action of these solar particles could strip the Earth of its protective layers, which shield us from the sun's ultraviolet radiations. It's clear that this magnetic bubble was key to helping Earth develop into a habitable planet. So that's why it's important. You can't Mickey Mouse around with the magnetosphere, just like you can't Mickey Mouse around with the ozone layer, which also protects Earth from the sun's deadly ultraviolet radiation, just like you can't Mickey Mouse around with all the systems on Earth. But, another fun fact here, it says magnetic field is what causes compass needles to point to the North Pole regardless of which way you turn. but the magnetic polarity of Earth could change, flipping the direction of the magnetic field. The geological record tells scientists that magnetic reversals take place about once every 400,000 years on average, but its timing is irregular. As far as they know, such a magnetic reversal doesn't cause any harm to life on Earth, but who was alive 400,000 years ago? Okay, not big science. And a reversal is very unlikely to happen for at least another 1,000 years. But when it does happen, compass needles are likely to point in many different directions for a few centuries while the switch is being made. After the switch is completed, they will all point south instead of north. And Earth's magnetic poles have reversed 183 times in the last 83 million years, and at least several 100,000 times in the past 106. The time intervals between reversals have fluctuated widely. Here they say it averages about 300,000 years, with the last one taking place around 780,000 years ago. So, yeah, we don't really know if that affects life on Earth, but Earth's magnetic field is just something to not Mickey Mouse around with, because it deflects most of the solar material sweeping towards us from our star at 100 million miles or more. So, even though it seems irrelevant, this inner core and the outer core, they're really important. The more you know, people. Stay tuned.